All right, so we're in chapter 5.7, and we're talking about coordinate geometry. And what we mean by coordinate geometry is we're using, instead of numbers for our points, for our x and our y, we're using variables a lot of times. So we're talking about how we can use variables to describe our coordinates. And our tools. The tools that we're going to use are the formulas that we talked about from yesterday. Our distance formula. And I'm just going to rewrite them so I have them all in one place. So our distance between x1, y1 and x2, y2 is the square root, and this is what we just did on our opener, x2 minus x1 squared plus y2 minus y1 squared. So that's our distance. The other thing that we'll use today is the midpoint. So the midpoint between these 2 points is x1 plus x2 divided by 2, and that's my x-coordinate, and y1 plus y2 divided by 2, and that's my y-coordinate. And I'm just going to write up above here, that's x and that's y, so remember we're talking about a point, a coordinate. And our slope. We'll use slope in coordinate geometry also. Slope is y2 minus y1 over x2 minus x1. And that's just another way of writing rise over run. So this tells me how far I go up or down. This tells me how far I go left or right. And the other thing that we might need to know a little bit about is parallel lines. How do the slopes of parallel lines compare to each other? You remember? If I have two lines that are like so, and they're parallel, what do we know about the slopes? The same. The slopes are the same. And perpendicular lines. Do you remember how the slopes of perpendicular lines are related? What is it?
The two numbers are switched.
Two numbers are switched and the sign is changed. Perfect. So what we call that is negative reciprocal. We flip the fraction and change the sign. So those are a couple of things that we might need to know using coordinate geometry. So what we're going to do for the rest of the notes is I'm just going to do a bunch of examples using coordinate geometry. So let's take a look at, we're going to calculate each of these using coordinate geometries, distance, midpoint, and slope, and then we'll work with some shapes. So an example. We want to find the distance between PQ, the point PQ, and RS. So we're using variables instead of numbers. Now to do this, we're going to use our distance formula just like we do when we have numbers. So I'm going to label this x1, y1 and x2, y2. Doesn't matter which are 1s and 2s as long as the 1s and 2s are together. And I'm just going to plug these points into the distance formula. So the distance equals the square root of x2 minus x1 r minus p squared plus y2 minus y1 s minus q squared. And that's as far as we can go, because we don't know what r, p, s, and q are. We don't know numbers for those. They're just variables. So that's how we would write the distance between those points. Questions on that? Treat them just like numbers, but because we don't have numbers once we get here, we can't calculate. So let's find the midpoints. Between the point 0, 0. So this time we do have a couple of numbers to work with. And 2p, 2q. So we'll do the same thing. I'm going to label this x1, y1, x2, y2, and plug these into the midpoint formula. So the midpoint is x2 plus x1, 2p plus 0, divided by 2, and the y-coordinate is 2q plus 0, y2 plus y1, divided by 2. And just as a reminder, this is a point. This is x and y. Now we can simplify this a little bit. What is 2p plus 0? If I added 0 to 2p, what am I left with? Just 2p. So this is 2p divided by 2. And 2q plus 0 is just 2q. And what happens to the 2's? They all cancel, right. So I get the point P, Q. And this is my x, and this is my y. So the point PQ would be the midpoint between 0, 0 and 2P, 2Q. Questions on that one? Yes. To the first page? Okay. Which part do you need to see? Okay. So we're calculating just like we do with numbers. We put our coordinates in place of the numbers, and calculate with them as much as we can. Oops, this should be slope. All right, you good? Okay. So let's do an example with slope. So we want to find the slope between the points PQ and RS. So we do the same thing. We plug in we label our points, x1, y1, x2, y2. And we plug these into our formula. So the slope, y2 minus y1, s minus q, over x2 minus x1, r minus p. And because I don't have I don't know the numbers that these represent. This is as far as I can go. So that's the slope between those 2 points. Now, some of the work that we're going to do involves these formulas. Other parts of it involve shapes. So let's take a look at how we're going to use coordinate geometry with shapes that we're familiar with. Anybody have any questions over distance, midpoint, and slope using our coordinate geometry? Okay, let's see how we're going to apply this to shapes. So I'm going to draw a shape on a set of coordinate axes. So this is X and Y. And what the problems usually involve with these is finding a missing point. We know we have points for each vertex of some shape, and we want to find the missing point. So the first one, we're going to do a rectangle. So I'm going to draw a rectangle in here. And we're going to call this ABCD. And we know the coordinates of our points. This is 0, 0. A is 0, 0. B is 0, P. C is question mark, question mark. That's what we're trying to figure out. And D is the point Q0. What's that? The problems look like, in the homework, the problems look like this. We're question mark, question mark. So we want to find C equals some point. Now the idea of these problems is when we're looking for the point, the first number tells us how far left or right. And the second number, our y-coordinate, tells us up and down. So we're trying to figure out how far left or right our point is and how far up or down our point is. And we're using what we know about the shape. So let's look at the left and right first. If this, how far to the right is point D on my graph? What does this tell us? We've moved over Q. This tells us that we've moved over to the right Q spaces. If this is, and we're going to say that, I forgot to write that ABCD is a rectangle. If ABCD is a rectangle and point D is over, we go to the right Q spaces, how far right have I moved to get to point C? It's the same. It's Q spaces. It's directly above point D. So I know that I go over Q spaces to get to C. How far up is point B? P. We go up P. So how far up is point C going to be? P. It's the same. So the coordinates of point C are Q, P. I go over Q and I go up P. Does that make sense? Okay. Let's look at one that's a little trickier. We're going to look at a parallelogram. So here are my axes for my parallelogram, and I'm going to put draw my parallelogram in red. So there's my parallelogram. And we're going to call the parallelogram DEFG. So we're going to say DEFG is a parallelogram. And let's give some coordinates with our points. D is 0, 0. E is the point C, B. F is our question mark, question mark. That's what we're trying to figure out. And G is A, 0. I need to move this because I'm going to need to draw something here. All right, so we want to find F, what the coordinates of F are. So what is going to be the easy one for the F, the left or right or the up or down? Left and right? So that's going to take a little more work. Up and down, so up and down is going to be pretty easy. So what's the up and down going to be? B. I've gone up B to get to point E. If this is a parallelogram, I have to go up the same distance to get to point F. So my up is B for point F. It's exactly the same distance up as point E. Now let's see what we need to do to figure out our left and right. I'm going to draw in a dotted line here. Right here. And I'm going to draw another one here. And we're going to say that these make 90-degree angles. So if point E, if I go over C units, C spaces, to get to point E, how long is this little segment here? C. That's C. I go over C to get to there. So that distance is C. If this is a parallelogram, how far over from G do I have to go to get to here? I have to go the same distance. If point G is at A to the right, and I go over C more spaces, how can I write how far I've gone total? A plus C. Perfect. Very nice. So the distance left or right is going to be A plus C. So that would be the coordinates of point F. I go over A and then C more, A plus C, and I go up B because it's the same distance up as point E. Questions on that? So we're just figuring out left and right, up and down. Let's look at one more with a triangle this time. Questions before I move on? Okay. Here are my axes for this one. Oops, I want a solid line here. And I'm going to put a point up here. And we're going to make a triangle. So we'll make our triangle in red. All right, and we're going to call this triangle ABC. So this is A, this is B, and this is C. And A is at 0, 0. B is at 2, 3. And C is at question mark, question mark. That's what we're trying to figure out here. And we're going to say that AB is congruent to BC. And we want to figure out what the coordinates of point C are. Which one, left or right, up and down for this one is going to be the easiest? For point C. Up and down, how far up is it? Point C? How far up? 0. We haven't gone up at all. So my up and down is just going to be 0. So my second number is going to be 0. Now we need to figure out the left and right. Anybody have an idea of how we might want to do this? Draw the tick marks, or what are you saying, Tyler? So we want to draw a dotted line from where?
From C straight up.
We could go C straight up and then over B. How about if I did it this way? That would work. Let's shortcut it a little bit. What if I did it here? And we know that this is a 90-degree angle. What does this segment do to the base of the triangle? What is it? Cuts it in half. This is an isosceles triangle. The altitude from the vertex to the base at a 90-degree angle cuts it in half. So how far is it from here to here? How far are we going over? We're going over 2, right? To go over here, I'm going over 2 units to the right. So how far does it have to be from here to here? Has to be another 2 units. So the whole distance is 4. So my coordinate, my x-coordinate, how far I've gone to the right is going to be 4. So my point C is at 4, 0. So these are some examples of how we're going to use coordinate geometry in the kinds of problems that we want to solve with coordinate geometry. Any questions? Okay.